Welcome friends, in this one let's take a look at multiplying matrices together and then some applications of matrix product. Get going here. So here we have, let me move myself aside, we have this matrix on the left side. Let's just take a look at some observations about this matrix. It's 3 by 4. 3 rows by 4 columns. This matrix on the other hand, as you can see, is 4 by 4. 4 rows by 4 columns. That means they can be multiplied. And the way to generate the entries is as follows. You're going to take this row and you're going to multiply first by this column, and now it'll give you the first entry. Let's work with that. So it's going to be 7 times -1 and then -5 times -9. Let's see. The next we're going to have here plus 1 times 6 and then plus 3 times 5. This is not hard, but you have to be very careful because it's a lot of multiplication, addition, and so on. So it's going to give you a value of 59. So this is 59. Now, take a look. Because this is a 3 by 4 and this is a 4 by 4, the resulting matrix that you get from this will look like the following. It's going to be a 3 by 4. And the 59 I've just generated will be the first entry in the matrix in that position. That's your 59. Then what you do is you take this and you scan over to the next one and you go through the same question. So 7 times -8 and then -5 times -2. Let's see, let me do that again. So -5 right here times -2, and then plus 1 times -5, and then let's see at the end, plus 3 times -7. So I've multiplied this row by the second column of the second matrix. You punch this in, that gives a value of -72. All right, -72, and this -72 then goes across the top here, right here, -72. Then you go on to the next one, so you take your column. Okay, you move over to that column. Notice the entire time I am not changing the row, right? The row is fixed at the first row in the matrix on the left. I'm just scanning across the columns of the second matrix when I do this. So next I'm going to have 7 times -4 minus 5 times 2 plus 1 times, let's see, 0, and then plus 3 times 7. You punch this into your calculator, and that gives you a value of -17. And that then becomes, right here, this entry, -17. Then you go on to the next one. You take your column scanner, so to speak, right? You move it over to here, and then you're going to multiply. So 7 times 3 minus 5 times -6 plus 1 times 1, and then plus 3 times 10. Punch this into your calculator as usual. So you go through that process, and that's going to give you a value here of 82 positive. So that's 82. That's the entry in this position right here. Each of these calculations that you see on the screen, this is called a dot product. Right? This here, again, this is called a dot product. You take the 7, you multiply by the 3. Then you add to it the -5 multiplied by the -6. Then you add to it the 1 multiplied by the 1. Then you add to it the 3 multiplied by 10. So this kind of calculation right here, it's called a dot product. Now, at the next stage, you reset everything. So in the matrix on the left, you move down to the next row, and then you take your column here, and then you reset that to the first column this way. And then you go to the dot product calculations one more time. So let's go through that process. You're going to have now -9 times -1 plus 0 times -9. To be so careful with these. And then -3 times 6. And then let's see, plus 2 times 5. So you punch these in, and that's going to give you a value of 1 apparently. So that means this entry is a 1 right here. Okay, good. Let me move this down, good. Next, then you take your column and you move over to the next column. Let me move this label down a little. So take your column and you're going to scan over to the next column this way. And then you go to the next dot product calculation. -9 times -8 plus 0 times -2. Let's see, -3 times -5, and then plus 2 times -7. You punch this into your calculator. All right, let me do that right now. So let's see, that's going to give us a value here equal to apparently 73. Let me double check, that's correct, 73. And that then becomes the entry in this position. Okay, then you continue with this process, that's all. So you're going to take this, move it over to the next column this way, and that's going to give you then the following. -9 times -4 plus 0 times 2, and then let's see, let's be careful here. -3 times 0, and then plus 2 times 7. You punch this into your calculator. So that now that's going to give you a value of 50. And that then becomes the entry in this position right here. That's your 50. Let me double check. That's good. Then you do this one more time. So you take your column, you move it over to here. And then again, you do the next dot product. So negative 9 times 3 plus 0 times negative 6 minus 3 times 1 and then plus 2 times 10. You punch this into your calculator and you get a value of negative 10. And that then becomes the entry right here. You really should pause the video and work out the values in the last row. I'm going to continue, but you really should try that, okay, as an exercise. So now I'm going to take this, I'm going to move it down to the last row, and I'm going to take my column and move it back to the first column, and I'm going to go through all the calculations one last time, calculations. So now you're going to have negative 7 multiplying negative 1, then you're going to have, let's see, be careful, minus 1 times negative 9, then 8 times 6 plus, so plus 8 times 6, and then minus 6 times 5. That's the dot product of the last row and the first column. And then that gives you a value of 34. So this becomes the entry in this position right here. That's 34. Then you go on to the next column. So scan over to the right a little bit. And then you're going to have negative 7 times negative 8. Minus 1 times negative 2. Plus 8 times negative 5. And then minus 6 times negative 7. All right, and then punch this into your calculator. So that gives a value of 60. That's correct, so that's 60. So it's going to be 60 here. You continue with this. It's got to be done 4 times. So you take this now. All right, focus on the third column in the second matrix. So this is now going to give us the following. You're going to have negative 7 multiplying negative, minus 1 times 2, plus 8 times 0, and then minus 6 times 7. So calculate this, punch it into your calculator. It should give a value of negative 16. So this is negative 16 in this position. All right, so that's that dot product. Let's finish up with the last one. So take your column, move it over to the last column of the second matrix, and again multiply. So negative 7 multiplying 3, minus 1 multiplying negative 6, and then plus 8 multiplying 1, and then minus 6 multiplying 10. Punch this into your calculator. So that now that's a value of negative 67. So this is negative 67. And this is how you do this kind of process. Notice the final matrix as a note. Final matrix is 3 by 4. In other words, if you think about it, there are 3 rows in the matrix on the left and 4 columns in the matrix on the right. So it ends up being a 3 by 4 with these specific entries. Those are some applications. A brass manufacturer makes 3 different types of wholesale brass blocks from copper and zinc according to the following matrix. Copper high brass 65%, copper Muntz metal 60%, copper gilding metals 95%, zinc high brass 35%, zinc Muntz metals 40%, and zinc gilding metal 5%. In addition, the demand in thousands of pounds, we'll get to that in a second, okay? For now, let's just look at the first one. It says, make a 2 by 3 matrix B that contains the blending information in decimal form. So you're going to make a 2 by 3. In other words, you just take this tabular display that you see here with copper as a row and zinc as a row, high brass, Muntz metal, and gilding metal, the type of metal, as a column. You just put the numbers in there. So 0.65 this way. For the next one, it's 0.6. For the next one, it's 0.95. Just convert them to decimal form. Next one in the bottom is 0.35. Next one is 0.4. And the last one is 0.05 because it's 5%. Remember, 5% means 5 over 100, right? Reminder, so 5% means 5 over 100, which is then 0.05. Okay, that's the first one. Let's look at the next question now in the process here. So it says, make a 3 by 2 matrix D for the demands at each plant. So to answer that, well, take a look. It says, in addition, the demand in thousands of pounds from plant 1 is 15 high brass, 4 Muntz metal, and 32 gilding metal. Okay, so you're going to make a 3 by 2 here, so 3 by 2. And you're going to have plant 1, so 15 high brass, 4 Muntz metal, and then 32 gilding metals. So 15, 4, and 32, that represents plant 1. And then you go over to plant 2, and notice it says for plant 2, it's 10 high brass, and let's see, 2 Muntz metal, And the last one is 25 gilding metal. So let me pull this down a little bit. Remember, this is, I'm going to call this P1 for plant 1, and this here is P2 for plant 2. And then this, well, the first one is basically the high brass. Let me label these rows. This is, let's see, Munz metal. And the last one then, as you can see, is, what was it? A gilding metal, like this. Let me write that down, gilding metal. So that's that matrix. Now look at the next one. It says, find the matrix product to find each location's need for each type of metal. Okay. So you're going to take your, let's see, the original one, there's 3 by 2. You're going to take that 3 by 2, and you're going to have to multiply by that one above, which is, let's see, 2 by 3. So you're going to have to multiply the matrices together, and they are compatible because you see the one on the left has 3 columns and the one on the right has 3 rows. So you'll be able to multiply this by this, add to it this multiplied by this, and then add to it this multiplied by this. It's going to work out for multiplication purposes. So let me put the values in here now. So 0.65 and then 0.6 and then 0.95. All right, let's see, what's next? That was a 0.05. The one before here was 0.4 and the previous one was 0.35. And you're going to multiply this by 15, 10, let's see, next one, 4, 2, and then 32 and 25. So from here, it's just a straightforward matrix multiplication question. All right, so I'm going to pull this up because I'm going to need room here to generate these entries. Now notice, let me stress this. This is a 2 by 3. This is a 3 by 2. So keep that in mind because that determines what happens. So you're going to do, now notice, what is this going to give us? So row 1 times column 1 is an entry. Row 1 times column 2 is an entry, second entry. Row 2 times column 1 is the third entry. And then row 2 times column 3 is the fourth entry. So it's going to give us, for that reason, a 2 by 2 in the end. Simple enough, actually. Let's go through the calculations. So let me bring in my row object. So this is going to represent the row that I'm working on, and this is going to represent the column that I'm working on. Keep that in mind. So it's going to be this. 0.65 times 15 plus 0.6 times 4 plus 0.95 times 32. So you work through this, and that's going to give you a value of 42.55. And that then becomes the first entry, 42.55, this way. All right, then you go over to the next column this way, and you're going to do here 0.65 times 10 plus 0.6 times 2 plus 0.95 times 25. Okay, and then you work through this. So that's going to give you a value of 31.45. So that comes over here, 31.45. Then you go on to the following. You're going to have to repeat this. So grab the bottom row and then come back over here and go back to the first column this way. And then you do the dot product between those. So 0.35 times 15 plus 0.4 times 4 plus 0.05 times 32 this way. And then you work through that. So punch this into your calculator. It's 8.45. So 8.45. There you go. So 8.45. Right. Now take the column and move over to the next column this way. So you're going to do the second row and the second column between the matrices. Dot them. So 0.35 times 10. Let's do it this way. Times 10. Let's see. Plus 0.4 times 2 plus 0.05 times 25. So you punch this into your calculator. It's going to give you a value here of 5.55. So it says find the matrix product to find each location's need for each type of metal. Those are the needs, essentially, those numbers. And now let's continue. Look at part D. If the price of zinc is $0.68 or 68 cents per pound, and the price of copper is $2.96 per pound, the total of cost of plant 1 and the total cost of plant 2. You're going to find those values. Now remember that this says the demand is in thousands of pounds. That means you're going to multiply this by 1,000. Scale each entry by 1,000 units. So in other words, like this. Not just 42.55 or 8.45 or 31.45 or 5.45, 5.55. What you have to do is you have to multiply each of these entries by 1,000 to get the, like this. So we're doing an example, in other words, of scalar multiplication. Same thing with this one, 1,000 times 8.45 or 5. And same thing with this one, 1,000 times 5.55. Let's simplify the entries here. So for the first one, when you do it, you're going to have 42,550. 42,550. for the next one. It's going to be 8,450. Remember, these are demands of metals. That's why the numbers should be big, right? You need a lot of metal, and metal is heavy. So those numbers should be big. Okay. So next one here. So 31,450. So 31,450. And then let me move that 3 aside. Got in there somehow. And the last value then is 5,550. All right, now we have the demands. Now look, it says if the price of zinc is 68 cents per pound and the price of copper is $2.96 per pound, the total cost of plant 1 is something. Now remember, this, go back over here to where we found the product matrix for the demands. So these values are the demands. 42550, that's the number of pounds, let's see, of copper, and the 8450, that's the number of pounds of zinc. So what you have to do is as follows. You're going to take the price of copper, 2.96, and you're going to multiply by 42550. So it's 2.96 per pounds times the number of pounds. And then plus, let's see, 0.68 multiplied by 8450. Then you punch this into your calculator, and you get a big number here. So $131,694, right? This is in money here, remember, because it's talking about the total cost. Okay, so that's the cost of getting all of the metals, both the copper and the zinc that is at plant 1. Then look at plant 2, so you're going to do 2.96 times the demand there, so it's 31450 plus, let's see, what's the next one? 0.68 times the 5550. You punch this into your calculator, and it's going to give you a value of 96,866. That's the total cost of the demand of copper and zinc at plant number 2. That's how you do this. Last application, a new website allows consumers to purchase various automobiles via the internet and then take delivery at a local dealer. The following table shows the retail price of the cars on the website. Okay, so you've got compact, midsize, luxury, and pickup, brand A and brand B. Now look, it says the dealer makes the following profit on compact cars, 7%, on midsize, 11%, on luxury, 8%, and on pickup trucks, 22%. Those are the profits. Then they give you this matrix. Use the following matrix and multiply the price to find the matrix of profit per car. So first of all, this matrix here, if you look at it, it's going to be a 4x2 matrix. Now I don't have one ready, so I'm going to have to proceed as follows. I need to add a couple of rows here, so give me 1 second here. All right, so that's this, and then this. Okay. So that's one, and then put the numbers in there. So this is going to be 17,000. This is going to be 11,000. You could also just put in 1711 and just multiply by 1,000 at the end, but 23,000. All right, next one here is going to be 30,000, 27,000. Next one is going to be 55,000, and the last one here is going to be 49,000. So we've got that part done. Those are the types of cars. Now you have this, what is this called? The profit matrix in terms of percents. So you're going to have to multiply them together. So you're going to have to take this matrix, and you're going to have to multiply by this matrix right here, okay? The question is, are they compatible for multiplication? Well, the answer is yes. Think about it, because observation, right? This, for example, is, what is this? This is 4x4, and this is 4x2. So when you calculate, what you will have is a 4x2 also. Let me put in my row, and then this is the column. So you're going to have the following left over. So a 4x2. In other words, a matrix that will have this shape right here, but just the entries have to be cleared out. So let me do that right now. I got to clear the entries out. Good. Now we go through the process. So you're going to do. The nice thing is, notice that in this row, all the entries except the first one, all the remaining entries are 0. So effectively, what you will have is just 0.07 times 17,000, and that's it. If you do the 0 times the 21 plus 0 times 27 plus 0 times 55, irrelevant. Then you go on to the next one, basically. So let me take this. Okay, let me move this label over. And then you're going to move it over to here, and then you go through that process. Again, we get lucky because only the 0.07 times the 11,000 is left over, correct? The 0 times the remaining 23, 0 times 30, and then 0 times 49,000, those go away. So you get lucky. Then you go on to the next row like this. So this is next row. Let me freeze the matrix so it doesn't do that. Okay. Then you take your column back to here, and you go through that process. Again, we get lucky. Why? Because all the entries in this row are 0 except the 0.11, which would multiply over to the 21,000. So it's going to be here 0.11 times 21,000. Then you take a column scanner, so to speak, and you move it over to here. And now the lucky thing is you're going to take the 0.11 and it's going to multiply only to the 23,000. So you're going to have 0.11 times 23,000 this way. That's it. Then you take your row scanner, so to speak, and move it down to here. You reset the column. All right, and now we are lucky again because the 0 and the 0 multiplied to the 17 is 0. 0 to the 21 is 0. The 0.08 to the 27,000 is not 0. So you're going to have 0.08 times 27,000. And then you're going to have at the end, let's see here, the 0 times the 55,000 is irrelevant, 0. Right. Then you take your column and you move that over to the next one here, and you go through that process. So again, the only thing that's not 0 is the 0.08 multiplying the 30,000. So 0.08 times the 30,000. Then you go on to the next one. You're going to have, move this down to the last row. Reset the column to the first column, and you go through that process. The last entry is 0.22. That's going to multiply to the 55,000. And that's it. The other ones are all 0. Then you're going to take the 0.22, okay, and that's going to multiply over to the 49,000. So it's going to be times 49,000, and that's it. That's going to be your matrix then. All right, so the next stage, we're going to have the following. You have to clean this up. So it's a lot of practical small level calculations. The first value in here, however you choose to do it, it's 1190, okay. All right, so that's done. Then you take this, you compute this. All right, let me see. That's going to give you a value of 770, okay? The next one there, you compute that. It's 2310. The next one, you compute that. It's going to be 2530. The next one is going to be 2160. The next one here is going to be 2400. The next one is going to be 12,100. And the last one is going to be 10,780. All right, there you go. So this is the profit per car. Now look at the last part, friends. It says, reading from the profit matrix, how much profit does the dealer make by selling 3 brand B mid-size cars? Okay, remember where things were. Brand B mid-size car, right? That was like this entry right here. Brand B mid-size car. So now that shows up in this matrix right here as this entry of 23,000 in this position. Brand B mid-size car. Why do I want to know that? Because what is that telling you, in other words? How do we relate this? So remember, this 23,000 that you see in this position, how do we get that, right? So we got that from here. And then when you multiply, let's be careful, okay? When you multiply the 0.11 by the 23,000, then this entry, what does that tell you? It tells you the profit, right? So the profit is right here, 2,530. But it says you're going to sell 3 of these, so then you're going to go 3 times 32530. You punch this in, and that's going to give you a value of 7,590, and this would be in dollars. And that's the profit for 3 brand B mid-size cars like that. That is it for this one. As you can see, matrix applications can be very interesting. You can do a lot with them. Just as a review, first we just reviewed multiplying matrices in a purely mathematical form with no meaning attached, right? Then we practiced applying matrices to writing them first, right? Then multiplying them, and then interpreting the multiplication, for example, as total costs. And the last one, again, it's a business application related to money, as you've seen here. So that is it. Please leave a like, please subscribe. I hope this has been helpful to you. I'll see you in another video. I think I'll post this PDF of this work on my website. I'll put the link in the lesson resources. Well, what I mean is in the description down below the video, okay? Thank you. I'll see you in the next video.